Hello, my dear students. Before starting, I just want all of you to be inquisitive in nature. Because if you are inquisitive, you can always excel in science. So, let us scratch our mind with some very simple activity. You all have to make a list of 10 things you have consumed since morning. And you have to sort that list according to the table given on the screen. I hope by now you must have sorted your list. And according to the table given on the screen, in the first column, let us match. You must have written in the things made of metal, almirah, spoon, etc. And in the things made of glass, you must have written mirror. And something very interesting, that in the third column, you must have written water, air, milk, sugar, clothes, maybe some tablets, maybe paper, and so on. Now, my question to you is, what these things, what these materials like clothes, milk, sugar, these tablets are made up of? Any guesses? Okay, so we will first do a small experiment and then we'll see what does it have. So let's go. We will simply take a tube and we'll hold it with a test tube holder. Now here one thing I just want you to please listen carefully. I have taken an expired tablet and I will burn that tablet in order to see whether it has some that unique substance or not. But you can try it out at home with paper, maybe with cloth and so on. And make sure you will not burn any type of medicine available at home. I am mentioning it again, I am burning an expired tablet. And in this U-tube, I have filled a colorless liquid known as lime water. After this setup, we will lamp the burner. Students, please do remember that if you are burning, you have to take out that burning process in presence of your parents or your guardians. And then we will start burning of our expired tablet. Students, observe it carefully. You have to focus on the area of the U-tube. Did you see any color change? Yes, that colorless liquid changes to milky white. What does it indicate? Students, you have studied it before in the previous chapters, that whenever you pass carbon dioxide, it turns lime water milky. And presence of carbon dioxide, my dear students, judge presence of carbon in that substance. Students, with this activity we came to know that many compounds have carbon, but you will be surprised to know that the availability of carbon, that is natural abundance of carbon, is very little. Then a question arises, what makes this carbon most versatile element? Yes, now we will find the answer of this question. Carbon is versatile element because of the two main properties. As you know, the atomic number of carbon is 6 and electronic configuration of carbon is 2, 4. And when you talk about its first property, that unique property is known as catenation. What is catenation? Catenation is self-linking property of carbon leading to formation of long chains of carbon or branch chains of carbon or circular, that is closed shape of carbon chains. And this is a task for you. You all have to take help of clay and toothstick and try to make some structures related to straight chain, branch chain and the circular chains of carbon. That means our point is catenation, which is self-linking property. The second property of carbon is tetravalency. You have studied in class 9th, valency means combining capacity of an element. combining capacity. When does an atom combine in order to become stable? Students, now carefully observe this three-dimensional structure for tetravalency. As you can see, in the center you have carbon, and these four lines represents the tetravalency, that is carbon share 4 electrons in order to become stable. Now let us revise these two properties quickly, and I want you people also to do it with me with help of clay and toothstick. I just wanted to tell you that in catenation you can make different structures which are straight chains, these balls as clay and the sticks with the bond. And you can make straight chain structures, you can make cyclic structures, and you can make branch structures out of it. At the same time, you can also make this tetrahedral structure of carbon with the toothpick, showing 4 bonds of carbon. So these two unique properties of carbon shows that carbon is the most versatile element. Okay, now my dear students, a simple question to you. What do you mean by word bond? Yes, rightly guessed. It's a kind of linkage or association. Okay, now again think, what type of bond you have studied in your previous chapter, that is metals and non-metals? Yes, again rightly guessed. It is ionic bond. So, what are ionic compounds? Ionic compounds are neutral chemical compounds made of positively charged ions known as cations and negatively charged ions known as anions, which happens to be by transferring of electron from a metal to a non-metal. And this association is a very strong association. But you have to imagine, my dear students, what will happen with carbon? How carbon will become stable? Question can come in your mind. Will it lose 4 electron? Or will it gain 4 electron? Or what will happen with carbon? My dear students, carbon will neither lose nor it will gain 4 electrons, as it is energetically not a favorable condition. That question arises, what will carbon do? Carbon will become stable by sharing of electrons. So let us understand the meaning of the term sharing. My dear students, whenever sharing of electron takes place, it forms covalent bonds between the elements. And such compounds where covalent bonds are formed, these compounds are known as covalent compounds. Let us explore some more covalent compounds. We'll start with one very basic compound. We'll take up hydrogen molecule. We all know that atomic mass of hydrogen is 1 as well as atomic number of hydrogen is 1. So when we'll do electronic configuration, it is 1. So the outermost electron is represented with 1 dot, as you can see. Now this hydrogen wants to become stable, but in its proximity there is no one to give the electron. How it will become stable? It will become stable by calling one more hydrogen, and this hydrogen also have 1 electron. Now what will they do? They will try to come close and share their electrons. Now you have to make sure that sharing is always shown with some circle. As you can see, this hydrogen is sharing its 1 electron of another hydrogen in its proximity, and again the second hydrogen also wants 1 more electron. And this way the sharing is being done between 2 hydrogen elements. Now if you can see, in this circle you have 2 electrons. You have to make sure, my dear students, these 2 electrons make 1 bond. So in order to represent this molecule, we will simply represent it with a single bond. That's why we say that in hydrogen molecule there is single covalent bond existence. In the same way, we can do another molecule that is oxygen molecule. We all know oxygen is represented with symbol O, and the atomic number of oxygen is 8 with electronic configuration 2, 6. Now, we will try to make electrons for oxygen. Oxygen has outermost 6 electrons. So, we will represent it with 6 cross. Now, oxygen also wants to become stable. So, it will call another friend oxygen, which also have 6 electrons in its outermost shell. Now, how they will become stable? They will also become stable by sharing of electrons. Now, carefully see how this sharing takes place. Now, this oxygen wants 2 more electrons to be shared. So, this way the sharing will take place for one oxygen. And you can see in a circle all 8 electrons are complete. In the same way, second oxygen also wants 8 electrons to be completed. So, this will also share the 2 electrons of another oxygen in association. Wow! How beautifully it is looking. Students, you can also try it with your own creativity. You can also bring that artist in you and do these things very, very creatively. But now, as you can see, there are 2 electrons, 2 pair of electrons. So, now we remove these 2 pair of electrons and represent these electrons with 2 lines, that is 2 bonds. See? It is double covalent bond. So good. Now, we will take up another molecule, that is nitrogen molecule. The symbol of nitrogen is N. Atomic number is 7 with electronic configuration 2, 5. So, this nitrogen will have 5 electrons in its outermost shell. So, we will represent it with 5 crosses. And this nitrogen molecule will become stable with another nitrogen molecule which also has same 5 electrons in the outermost shell. Now, they will also share 3 electrons each. Students, as we have done for oxygen molecule, same way the task for you is you have to do it for nitrogen molecule. We will take up a molecule which consists of carbon for the better understanding for the sharing of electrons by carbon. So, a molecule which we will study is carbon dioxide, which is very famous gas. We all know that carbon has atomic number 6 with electronic configuration 2, 4 and oxygen has atomic number 8 with electronic configuration 2, 6. So, first we will make the symbol of carbon like this and we will put 4 dots for carbon indicating the 4 valence electron. Now, I will put up one oxygen as it is carbon dioxide and then I will put up 6 electrons in the outermost electrons. Now, try to look it carefully. This oxygen wants to become stable by sharing 2 electrons. So, it will try to share up with carbon like this in a circle. But carbon is still not stable. Carbon wants to become stable again. It will request one more oxygen to come in association and this oxygen also have 6 electrons in its outermost shell. Again, this oxygen will become stable by sharing 2 electrons with carbon like this. How beautiful it is looking. But carbon, it is still not stable. We have to show the sharing with the carbon. So, what will carbon do? Carbon will share 4 electrons, 2 with each oxygen. So this way, carbon also has shared its 4 electrons. So see, now the property of tetravalency is completed. Carbon is stable, oxygen is also stable, and the second oxygen is also stable. And in order to represent this in other better manner, we will remove these electrons and we'll represent, remember, we'll represent the 2 electrons with a bond. So these are the double bonds in between carbon and oxygen. How beautiful it is looking. So students, please try this type of creativity for some more questions as given on the screen in the practice sheet. You have to try it for nitrogen molecule, carbon tetrachloride, methane, fluorine, chlorine, and so on. So I hope you like this creativity. Students, do you know diamond and graphite are same? Same? Unbelievable. How they are same? Yes, you have to note this point here. Chemically, diamond and graphite are same. That means if you burn both of them and you try to repeat the same process of passing the gas released from these compounds into lime water, it will turn milky and it will show the presence of carbon dioxide gas. That means chemically, both of these diamond and graphite is made up of carbon. But physically they are different. That means when you look at its structural carefully, it is different. How they are different? They are different in physical properties, but they are same in chemical properties. This phenomena is known as allotropes, and allotropes of carbon are basically diamond, graphite and fluorines. First we'll talk about diamond. As you can see the structure shown here, diamond, each carbon is bonded with 4 different carbons. We'll try to do it with some colored clays. Students, you know, carbon is represented with black, but just to have fun, we are just playing with some clay. We can simply take toothpick and we can make structure of diamond on our own. We have to make sure each carbon is surrounded with 4 different carbons. Now same way, you will repeat this step in order to look the 3-dimensional structure and you will get this structure of diamond. And what is the observation which we get? The observation is the structure of diamond is very compact. It is the hardest substance known. And if you look at its conductivity, diamond is non-conductor of electricity because there is no free electrons. As you can see, each carbon is bonded with 4 different bonds. Diamond is also used for cutting glasses. It is highly compact, so it has high melting point. You can tabulate these points as per the table given on the screen. Okay, my students, let's talk about another allotrope of carbon known as graphite. As you can see, graphite has a layered structure. It is soft and slippery, and once you take out the melting point, it is not that high as that of diamond. And when you look at the structure of graphite clearly, you can again have that fun activity of making its 3-dimensional structure. As you can see, I have drawn the structure of graphite in the form of a hexagon ring. You can continue making these hexagons with help of clay. You have to do it in a careful manner, where my focus is on this part, that each carbon is bonded with 3 other carbons. Same way, you will continue making the hexagons and you will achieve this type of the layered structure. Make sure in graphite there is presence of 1 free electron, as I have shown you. So, graphite is a good conductor of electricity. Students, let us talk about fluorines, which is also allotrope of carbon. and it appears to be like football, as you can see it on the screen. It is 20 hexagon and 12 pentagon rings interlinked with each other. Now students, let us recall what we did in this episode. We started with test of carbon. Then we have done versatile nature of carbon. We also have done covalent bonding structures and we have done allotropes. So you will be able to draw electron dot structures and show your creativity by making models of those structures using eco-friendly material. Hello my dear students. So far we have learned that carbon exhibits property of catenation and tetravalency. These properties will help us understand about organic compounds like hydrocarbons, which are made up of carbon and hydrogen. Hydrocarbons are of two types broadly, and you can see on the screen. First type is saturated hydrocarbons. These hydrocarbons contain only single bond between carbon atoms. As you can see in the given structure, this is a type of saturated hydrocarbon, where these black balls represent carbon and these white balls represent hydrogen. So as you can see in this structure, in between two carbons there is a single bond. So these type of hydrocarbons are called saturated hydrocarbons. The example of saturated hydrocarbons are alkanes. The another type of hydrocarbon is unsaturated hydrocarbon. In unsaturated hydrocarbon, you have this type of a structure where in between two carbon atoms you have a double bond. As you can see here, two carbons are attached with a double bond, and then in order to satisfy tetravalency, this carbon is bonded with another two hydrogens, and in this carbon also two hydrogens are bonded. These type of hydrocarbons in which double bond is present in between carbon atom are known as alkenes. There is one more type of unsaturated hydrocarbon which is known as alkynes. As you can see, in between two carbon atoms there is presence of three bonds, that is triple bond. These type of hydrocarbons are also called unsaturated hydrocarbons and their name is alkynes. There is one more thing you have to focus on. In the first structure, I talked about two carbons. So the root word is eth, and the one which has single bond, it ends with ane. So the name of this structure becomes ethane. Same way, if you talk about second type of hydrocarbon, that is unsaturated hydrocarbon, alkenes, double bond is present. So when we name it, there are two carbons, so root word becomes eth, and because of the double bond, it ends with ene. So its name is ethene. In the third type of hydrocarbon, that is unsaturated hydrocarbon only, but triple bond presence in between two carbon, it is alkynes. But because two carbons are there, the root word becomes eth, and triple bond, it ends with ines. So its name becomes ethyne. Now my young scientists, Let us have fun in creating series of these saturated and unsaturated hydrocarbons with clay and toothpick and try to fill given table on the screen one by one. First, we will talk about alkanes in detail. When I talk about alkanes, as you can see in this clay and toothpick structure, this purple colored ball represents carbon. As you know, carbon is represented with black balls, but here, just to have fun, we are creating some different colors. So, in the center, it is carbon, and these 4 bonds represents hydrogen. When you look at general formula of alkanes, it is CnH2n plus 2. Please have a look on screen for this. Here n is small n, which represent number of carbon atoms. So, in the first member, n is equal to 1. So, it is first carbon and tetravalency is there with 4 hydrogens. So, the molecular formula, when you put n is equal to 1 in the formula, it becomes CH4. This is the structure. And when you will count number of bonds here, it is 1, 2, 3 and 4. So, there are 4 covalent bonds. And if you will name it, when one carbon is there, its name starts with root word meth. And since single bond is there, it is ane, which is the ending word. So, when you combine both the words, it becomes methane. When you will form the second member, it is somewhat of this sort, where you can see 2 carbons are there and in between there is one bond which shows catenation and 3 hydrogens are being put in each of the carbon. So, this is a representation of second member of your alkane series, which has molecular formula C2H6. So, its name will be eth because there is presence of 2 carbons and it ends with ane. So, the name becomes ethane. Very good. So, when we talk about the number of bonds, you can count 1, 2, 3, 4, 5, 6 and 7. So, number of bonds are 7 in structure of ethane. The same way you will propose the structure of propane. You can take help from the table given on the screen. My dear students, we have already done electron dot structures of carbon dioxide and oxygen molecule. We will take help of that idea and will try to draw electron dot structure of ethane. Please have a look on the screen. Here you can see one carbon has 4 electrons in the outermost shell and another carbon also have 4 electrons in the outermost shell, and hydrogen have 1 electron in the outermost shell. So, all hydrogens will share its 1 electron with 1 electron of carbon, and remaining 1 electron of each carbon will form a bond with themselves in order to satisfy its valency. My dear students, the task for you is to draw electron dot structure for propane and have fun. There is one more thing you must have noticed. If you look at the series as per the table, that these are group of carbon compounds having similar structures, similar chemical properties, and whose successive members differ by a CH2 group. You have to carefully see one thing. As you have seen the first member of alkane, that is methane, with 4 single bonds, and if you try to compare this structure with this, there is presence of 1 CH2 bond extra. So, when each successive member differs by a CH2 group and you form a series out of it, that series is known as homologous series. Now it's a time where you need to scratch your mind. Think, what will be the first member of alkene series and what will be the first member of alkyne series? Okay, tell me, will it have 1 carbon or 2 carbon? Students, homologous series of alkene and alkyne starts with n is equal to 2. That means minimum of carbons required is 2 to start the series. Let us find out the reason why is it so. When we'll draw the structure of alkane's first member. Let's suppose these are two carbons catenated with one single bond. Since we are talking about alkenes, there will be two single bonds and it will make a double bond like this. Now, in order to satisfy valency, how many hydrogens should I put here with this carbon? Since two valencies are satisfied, I'll put two more. Same way, in this carbon, I have to put two hydrogens. We'll place red balls for hydrogen. Now, as you can see, minimum carbons are 2. If suppose I start my series with n is equal to 1, then this would have been a structure which appears to be so wrong. Here, if I put hydrogen, then hydrogen valency becomes 2. So, it is wrong. Minimum carbons which starts the series is n is equal to 2. So, first member of alkene is ethene. Eth is for 2 carbons and ene is for minimum one double bond present between the two carbons. So, the name becomes ethene. So, when you count number of hydrogens for this and number of total bonds, how many it comes? 1, 2, 3, 4, 5 and 6. So, in ethene you have 6 total number of covalent bonds. And please have a look on the screen to complete the entire table for alkenes. You will also draw the electron dot structures as discussed before with alkanes. Now we'll come to alkynes. Same way, if I want first member of alkynes, see, in between two carbons there is 3 bonds. Had it been only one carbon, I cannot put hydrogen here because now hydrogen valency becomes 3, which is wrong. So, minimum of 2 carbons should be there in between 3 double bonds, and then you will satisfy its tetravalency by placing hydrogens. So, in the first carbon, only one hydrogen will come, and in the second carbon, one hydrogen will come. So, now count total number of bonds with me. Very good. 1, 2, 3, 4 and 5. So, total number of covalent bonds in the first member of alkyne series is 5. And the name, because 2 carbons are there, root word becomes eth, and triple bond, then it ends with yne, Y-N-E. So, the name becomes ethyne. In the same way, you will draw electron dot structures for unsaturated compounds containing triple bonds. That is a task for you, my dear students. In addition to straight chains, you have cyclic structures as well. So, in order to have information about cyclic structures, my dear students, please have a look on screen. When you talk about cyclic structures and when you talk about single bond, let me show you one example. In cyclic structures, the general formula is CnH2n, which is same as that of alkenes. If suppose I want to make the structure of cycloalkanes, the simplest cycloalkane is with 3 members. I'll attach 2 carbons with a single bond. Then I want to make a cyclic structure out of it. So, see, I tried to make a circle in a triangular shape. So, this is a cyclic structure for alkanes with 3 carbons. In the same way, you can form the structure with 4 carbons, 5 carbons, 6 carbons and have fun. The second type which we need to understand, we have to discuss benzene. In benzene, there are total of 6 carbons with presence of alternate double bonds. Let's try to correlate its structure. Please try to see and then I'll tell you what I have done. please see. Here 6 carbons are there which are represented with purple balls, and alternate double bonds are present. These are 2 double bonds, then I have left this 1 bond. Then there are 2 double bonds, left 1 bond. Then again there are 2 double bonds, left 1 bond. Still carbon valency is not complete. We will try to complete by placing 1 stick for hydrogens. So in all the carbons, 1 stick will come and will attach red balls for hydrogen. So you can have fun in creating these structures, and the general formula is CnHn. Benzene formula becomes C6H6 as we took 6 carbon atoms. Up till now, we just have a vision of hydrocarbons containing carbon and hydrogen. But what if, my dear students, in addition to carbon and hydrogen, I have some another heteroatom like oxygen? Let us talk about functional groups. An atom or a group of atoms which decides the properties of a carbon compound is called a functional group. As you can see on the screen in the given table, the functional groups containing hydrogen have been classified as 4 types. The first is alcohol. In alcohol, the presence of OH group is mandatory. Now this is the representation of OH. This red ball represents oxygen and this purple ball represents H. There is presence of 1 bond between this OH, and you have to make sure this point that 1 valency of OH is free, which makes this OH a terminal group. I'll explain what is the meaning of terminal group right now. Let's suppose I have formed alkane methane. This is the structure of methane, 1 carbon and 4 hydrogens. Now I want to remove 1 hydrogen, and I made 1 valency free for methane. Now this group where I remove 1 hydrogen from methane, these groups are known as alkyl groups. Where methane, I removed 1 hydrogen, the group becomes methyl. In the same way, when we talk about, let us talk about this, 1 hydrogen is removed, this group becomes ethyl. So when we talk about methane, first we'll talk about this, we'll talk about methane after removing 1 hydrogen. Now my OH also have 1 free valency. So now what I'll do, please see, I'll simply complete this 1 valency by attaching this OH group. Wow, this is my first member of alcohol, where the formula, or you can say the molecular formula, is CH3OH. This is carbon, this is 3 hydrogen, this is oxygen. Just a second, we'll represent hydrogen with same colors, this way. So this is my structure for first member of alcohol. That is 1 carbon, root word is meth. Since it was a derivative of anes, methanes, so we'll write meth, then we'll write ane, and once I have attached OH group, the secondary suffix is ol, that is OL. So as you can see on the screen, the name of this compound becomes methanol. And if you'll count number of bonds, let us count 1, 2, 3, 4, 5. So total number of covalent bonds in first member of alcohol is 5. You can create your own electron dot structures the way it was explained before. Now if I want to make second member, I already told you about homologous series in alkanes, that successive member differs with CH2 group. So if I want to suppose make the second member of alcohol family, so I'll simply attach CH2 group. How? Please see. This is my carbon. Two hydrogens. Let us represent hydrogen with the same color in order to avoid confusion. Now see what I am going to do. So this was my first member of alcohol. So I'll simply attach, please look carefully. I'll simply attach a CH2 group and then I'll attach this OH. So the first member and the second member differs only by a CH2 group. So if you count number of bonds now, it becomes 1, 2, 3, 4, 5, 6, 7, 8. So total number of covalent bonds in the second member of alcohol family is 8. If you try to name it, there are 2 carbons. So root word becomes eth. Very good. And all single bonds, so primary suffix becomes ane. And in the last, because OH group is present, so it will have all. So name becomes ethanol. So if you look at the formula of ethanol, what it will be? It is C2H5OH. Very good. Now you can make your own series for other members of alcohol. Let us talk about second type of functional group known as aldehydes. If you look at the basic structure of an aldehyde, please see this ball represents carbon, which is purple in color. Now as you can see, oxygen has 2 valency, we already know that. As you can see, brown ball, it represents oxygen showing 2 valency, and this white ball represents hydrogen showing 1 valency. And if you see carefully, here also 1 valency is free for aldehydic group. So again, if I want to make first member of aldehyde, already 1 carbon is there. So tell me, should I place 1 carbon more or should I place something else? Yes, I have to place only 1 hydrogen. I'll not place carbon because already carbon is there in the functional group. So this is my first member of aldehyde. With total number of bonds, let's count 1, 2, 3 and 4. And since 1 carbon is there, it is root word meth. All are derived from alkanes, anes, and the suffix which will put, the secondary suffix which will put, it is al, ul. So the overall name becomes methanol. In the same way, if I want to make second member, what I have to do? Again, I have to place 1 CH2 group for the second member. So you can place it and have fun with your own creativity. Our third type of functional group is carboxylic acid, where, as you can see the structure, this purple ball represents carbon, brown ball represents oxygen with 2 bonds. And student, this is just the OH bond which I was talking about in alcohol. So this is OH, oxygen represented with red ball and hydrogen represented with white ball. But if you will carefully see, here also 1 valency is free. This is also a terminal group. So if I want to make first member of carboxylic acid series, what will I do? I have to place 1 hydrogen only, yes, because already there is presence of 1 carbon. And if suppose I want to make second member, what will I do? Please follow homologous series pattern, that is attaching CH2 group. Very good. So if I want to suppose count number of bonds in the first member, it is 1, 2, 3, 4 and 5. And if I want to name it, how will I name it? 1 carbon means meth, all derived from alkanes, primary suffix is ane, and because carboxylic acid is attached as a functional group, then its secondary suffix will be oic acid. So if I combine all the 3 things, it will become methanoic acid. For the other members, please have a look on the screen and try to make your own structures. Now my dear students, question time. Can we make ketone with n is equal to 1 or n is equal to 2? That means, can I make ketone with 1 carbon or 2 carbon? Please think. No, minimum we need n is equal to 3. That means, if we want to form a ketone, we need minimum of 3 carbons. Please understand how. This is the representation of a ketonic group, where purple ball represent carbon and brown ball represent oxygen. Oxygen has valency 2, we already know, so 2 bonds. And here this time, 2 valencies are free for this group. That means This is something unique. In carbonyl, that is C double bond O, which is a representation of ketone, you have 2 free valencies. So, it's a non-terminal group. Suppose if I want to make the first member, I have to place 2 carbons here. So, let's see, I am placing 1 carbon here and second carbon here. Now, for this carbon, only 1 valency is satisfied. How many valencies I have to satisfy as a whole? Total of 4. So, how many bonds will I make? 3 more. And hydrogens with red color ball, suppose. In this carbon also, how many bonds? 3. Very good. So, have a look at the structure. This is the structure for ketone. In between, you have C double bond O. In the sides, 2 carbons, making it to be a non-terminal group, and valencies are satisfied with hydrogens. So, its formula becomes CH3, CO, CH3. And how many bonds are there? Let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So, total number of covalent bonds present in the first member of ketonic family is how many? 10. And what will be the name? 3 carbons, so root word will be prop. All are derived from alkanes, so primary suffix will be ane, and at the end with the secondary suffix ONE is the representation for ketones. So, overall name becomes propanone. Very good. So, for the second member, please create your own fun structures and try to complete the table. Now, my dear students, let us understand some rules for naming carbon compounds. As you can see, first example in front of you. For naming carbon compounds, the first rule is selection of longest carbon chain. In the given example, we come to know that 1, 2, 3, 4, 5, 6. This can be a longest carbon chain, or 1, 2, 3, 4, 5, 6. This can also be the longest carbon chain. So, which one I should select? I should select the simple straight chain like this. Now, my second rule is to number this carbon chain, and I will number it in a way that the substituents which are present should get the lowest possible number. So, for simplicity, I am numbering it from both the sides. First, I will number from left to right, 1, 2, 3, 4, 5, 6. And then I will number it from right to left, 1, 2, 3, 4, 5, 6. Now, which numbering is correct? The correct numbering is the upper one, because here the substituents are getting the possible lowest number. Now, when we will come to name of this compound, first, as I told you in the previous slide, first part is prefix. So, here there are 2 prefix, ethyl and methyl. When we will go alphabetically, first we will write ethyl. Position of ethyl is 4. So, we will write 4-ethyl. Then position of second prefix, that is methyl, and we will write 2-methyl for that. Now, in the main chain, I have 6 carbons. So, root word becomes hex. Very good. And since all single bonds are there, primary suffix will be ane, A-N-E. So, overall name of this compound become 4-ethyl, 2-methyl hexane. Let us go with the second example. Now, first rule is selection of longest carbon chain. But here we need to focus a lot. As we can see in this example, there is presence of a double bond, that is unsaturation. Whenever you see this kind of an example, you need to make the longest carbon chain which include this double bond. So, when I am selecting my double bond and the longest chain, I will circle it in this way. Very good. Now when I do the numbering, always the numbering should start from double bond. So my numbering will be 1, 2, 3, 4, 5 and 6. So for naming this compound, as you can see, the substituents are present on 5th position. And if you take care of this point that there are 2 substituents present and both are methyl. So how do we write it? 5, 5 dimethyl, that is your first part which is prefix. Second part is your main chain. How many carbons are present? 6. Very good. So we will write root word hex. And in the third part which we talk about primary suffix, it is presence of which bond? Double bond. Very good. So we will write ene. And in front of ene, we will also specify position. And this position is 1 for double bond. So overall name becomes 5, 5 dimethyl hex 1-ene. So my dear students, happy learning and keep practicing. My dear students, so far we have learnt about naming of organic compounds. So I know now you can name any kind of carbon compound. This will help you understand chemical properties of carbon compounds. First type of reaction which we have to study is combustion reaction. Carbon in all its allotropic forms burns in oxygen to give carbon dioxide along with release of heat and light. You have to take note of this point that saturated hydrocarbon generally give blue flame, whereas unsaturated hydrocarbon give a yellow flame with a black smoke. But you also have to remember this, in actual state, type of flame depends upon oxygen supplied. That is, incomplete combustion in limited or insufficient supply of air leads to smoky flame. Now there is a task for you. You must have seen burning of camphor. If you have not, please try it out. When you'll take a piece of camphor on a spatula and if you burn it, you will see yellow and smoky flame. What is the reason? In the structure of camphor, there is presence of unsaturated bonds. And try to correlate with burning of alcohol. What outcome you will get? Alcohol is a cleaner fuel. When you will burn it, you will get blue flame because it burns completely and it have saturated bonds. So this is a task for you and you'll do that. Have fun in doing so. If you place a metal plate also when you are burning camphor, you will find the deposition of that smoky flame or that smoke on the plate. So you can correlate your information with that. Why do substances burn with and without a flame? My dear students, look for the answer for this question. Our next reaction is substitution reaction. Saturated hydrocarbons are fairly unreactive and are inert in presence of most of the reagents. However, in presence of sunlight, chlorine is added to hydrocarbon and it is a very fast reaction. Chlorine can replace the hydrogen atom one by one. It is called substitution reaction because one type of atom or a group of atom takes the place of another. It happens in saturated hydrocarbons. You have to take a point this also. A number of products are usually formed with higher homologue of alkanes. For the chemical equation involved, please have a look on the screen. Here you can see how One chlorine is replacing hydrogen of this saturated hydrocarbon. Our next reaction is oxidation reaction. Carbon compounds can be easily oxidized on combustion. In addition to complete oxidation, we have reactions in which alcohols are converted to carboxylic acids. And in presence of what? There are two kinds of reagents which are used. First is alkaline potassium permanganate, which is a mixture of potassium permanganate and any sort of alkali, that can be NaOH. Or acidified potassium dichromate, which is a mixture of potassium dichromate and any kind of acid like H2SO4. Please have a look on the screen for understanding the reaction. On the left hand side, you will take alcohol, which you need to oxidize, and you're already aware by now that in above the arrow, you have to write the reagents. So here, I have used a reagent, either alkaline potassium permanganate or acidified potassium dichromate. And what is the result? Result is formation of carboxylic acid. Here also you have to take note of an important point. The number of carbons which were there in alcohol, same number of carbons will be there in the acidic side. So try to write this reaction and have fun. Addition reactions is the last reactions which we'll talk about. Unsaturated hydrocarbons add hydrogen in the presence of catalysts such as palladium or nickel to give saturated hydrocarbon. Now a question arises, what are catalysts? Catalysts are the substances that cause a reaction to occur or proceed at a different rate without the reaction itself being affected. This reaction is commonly used in the hydrogenation of vegetable oils using a nickel catalyst. Now a question for you again. Which type of oil should we use in cooking? Saturated oil or unsaturated oil? Oils containing unsaturated fatty acids should be chosen for cooking because vegetable oils generally have long unsaturated carbon chains, while animal fat has saturated carbon chain. Vegetable oils are healthy, but animal fats generally contain saturated fatty acids. It can be harmful for your health. So, if you look at the equation on the left hand side, as you can see, we have an alkene with a double bond in between two carbons, and on the arrow we have written some conditions, that is presence of catalyst, and as a result we have formed alkane. Now you have already learned balancing in your previous chapter, so the task for you is to write a balanced chemical equation. Some important compounds are also there. Our first compound is ethanol. I told you the formula of ethanol. Please relate. The formula is C2H5OH. That means presence of OH group. If you talk about general properties of ethanol, it is a colorless liquid with a pleasant smell and burning taste. It is soluble in water. But do you know alcohol affects living beings a lot? Have you ever thought about it? My dear students, consuming alcohol affects the central nervous system, and an individual may not realize that his or her sense of timing and muscular coordination gets seriously impaired. Do you know, children, methanol is oxidized to methanol in the liver. So, you have to look for the answer. Why? Actually, methanol is poisonous. And my dear students, if we use alcohol, that is methanol, for drinking purposes, it converts into methanol, which actually harms your cell. It coagulates your protoplasm. And for your information, alcohol is a cleaner fuel. Look for the reason why it is a cleaner fuel. Why do we use it? My dear students, you have already learned that when acid reacts with metal, which gas is released? Come on students, think. Yes, hydrogen gas. And what is the test of that hydrogen gas? Pop sound. So my dear students, task for you. You have to add a small grain of sodium metal in alcohol and see what happens. Which gas is released? You will find hydrogen gas is released. But make sure you carry out this reaction in presence of your teacher because extra precautions is needed. And when you test the presence of this gas, it is pop sound. You know how to do it. So please try and explore. Ethanol reacts with hot concentrated sulfuric acid to form ethene. For the reaction, please have a look on the screen. My dear students, for your information, I should tell you, concentrated sulfuric acid is a dehydrating agent, which means it removes water from ethanol. So, please have a look for the reaction on the screen. If you take alcohol, that is ethanol, and you add few drops of concentrated sulfuric acid, it will remove water from it. And what it will form? It will form C2H4. Now you have to tell me, what is the name of this molecular formula C2H4? Very good. It is alkene, which is ethene because it is 2 carbons and 4 hydrogens. Ethanol is used for making alcoholic drinks. It is used as a solvent and it is used for making medicines like tincture of iodine. Our next compound is ethanoic acid. Now you have to tell me the formula. We have already done that. Yes. Formula is CH3COOH because it is presence of 2 carbons. The common name of ethanoic acid is acetic acid. Let's talk about its basic properties. Ethanoic acid is a colorless liquid with a pungent smell and sour taste. It is soluble in water. And if you talk about the most common ethanoic acid found at home is vinegar, which is 5 to 8% of ethanoic acid. My dear students, next reaction which we have to study in ethanoic acid is esterification reaction. And for understanding esterification reaction, let us have a look on the setup. In the setup, first I will take a tripod stand. I will put wire gauze over it. Then I'll take this kind of a setup where I have taken a beaker filled with some water, considering as a water bath. In the test tube, I added 3 things. First, 1 ml of ethanol, then 1 ml of ethanoic acid and only few drops, let's suppose 1 to 2 drops of concentrated sulfuric acid. Then I have to keep burning spirit lamp like this and I have to wait for 4 to 5 minutes. Once time is over, eventually you will have a smell of fruits. It will be a fruity smell. And how do I experience that? The vapors of that fruity smell I'll waft and I'll experience. I know you are not able to smell it, but explore in your lab in presence of your teacher and experience this smell. Now my dear students, please have a look on the screen for knowing the reaction. In the reaction, ethanoic acid, which is CH3COOH, reacts with ethanol, which is C2H5OH, and above the arrow you will write concentrated sulfuric acid. Now you know concentrated sulfuric acid is a dehydrating agent. It will remove water from both of the initial reactants and it will form fruity smelling compound known as ester, whose formula is CH3COOC2H5 and water. The reaction between carboxylic acid and alcohol is always used to form an ester. This reaction is known as esterification reaction. My dear students, let us understand another reaction of ethanoic acid. For that, I have taken this kind of a tube, that is a U-tube. If you can see, in this I have added sodium hydrogen carbonate and in this area I have added lime water. As you can see, it's a colorless liquid right now. What I have to do? I have to add ethanoic acid in this and I have to see what happens. Students, we have already done this reaction before. If I add few drops of ethanoic acid As you can see some bubbles, that means reaction has initiated. My dear students, have a look. That colorless liquid, that is lime water, changes to milky white. What does it indicate? That the gas which was released is carbon dioxide gas, and when it passes through lime water, it turns it to be milky. So, for the reaction, please have a look on the screen. Here I have used sodium hydrogen carbonate. You can use any carbonate, maybe sodium carbonate, and so on. My dear students, as we have seen in this reaction, lime water was taken in a U-tube, and when I passed carbon dioxide gas, it changes its color to milky white. Now question arises, if I keep lime water undisturbed for some time, will it change its color? This is a question for you to think. Explore and find out the answer. Next reaction is saponification reaction, and it is in direct link with esterification reaction. Students, you should know that we have done in esterification where alcohol reacts with acid in presence of concentrated sulfuric acid, and we got ester, which was a fruity smelling compound whose formula is CH3COO C2H5. Now we have to take this ester and treat it with NaOH. That means we are doing alkaline hydrolysis of ester. So my reactant becomes CH3COO C2H5 plus NaOH. Now please have a look on screen for products of this reaction. Our products will be CH3COONA plus C2H5OH. This is actually preparation of soap. What are soap? Soaps are long chain sodium or potassium salt of carboxylic acid. One of the famous example is sodium stearate. Now you have to understand structure of soap. Please have a look on the screen. Soap molecule have two parts. First part is hydrocarbon part, which is known as hydrophobic, water repelling. As you can see on the screen, this zigzag line represents hydrophobic part, and this part is water repelling, but it is soluble in oil. And the second part in the soap is ionic part, which is also known as hydrophilic part, which is also considered as water attracting part, and it is insoluble in oil. Okay, my dear students, let us perform one interesting activity. We will take two test tubes. Each test tube will be filled with equal amount of water, and in one of the test tube, we will add 1 or 2 drops of any cooking oil. After that, one by one, we will add soap solution in equal amount in both the test tubes. And then we will have equal number of shaking in both the test tubes. And let's see, what do we observe? This is the test tube in which oil is added. We will add 2 ml of soap solution. Now we will do shaking of this test tube. Now please do remember, when you are doing shaking, it will have equal number of shakes. Let's see how. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you can see oil is dissolved, and this kind of a liquid is emulsion. When I'll do the same with the test tube with water, we'll again do shaking of this test tube. You can see foam, but our purpose was to understand cleansing action of soap. That means our soap molecule help us dissolve the oil droplet. Now my dear students, please have a look on the screen to understand cleansing action of soap better. When soap is dissolved in water, it forms spherical structure called micelle. In each micelle, the soap molecule are arranged radially such that the hydrocarbon part is towards the center and the ionic part is towards outside. The hydrocarbon part dissolves the dirt, that is oil or grease, and forms an emulsion at the center of the micelle, which can be washed away by water. Now, my dear students, a question for you. What will happen if we use alcohol as solvent for washing? Will it behave same as water? Try to find out. Students, there is another task for you. Prepare your own soap. And how to prepare for that? Take help of internet or any book from library and try to find out. And students, if you want your soap to have good aroma, you can add few petals of rose. Students, let us perform one more activity. We have 2 samples of water in equal amount. Now, we will add soap solution in both of it in equal amount again. And what we want to see? Which one is hard and which one is soft. So let us see one by one. As we can see, there is some layer of foam. Now we will perform same with other test tube. Now, my dear students, if we compare both of the test tubes, we can easily see more foam is there in this test tube, in my right hand. So, we can say this test tube, this water is more softer than the water taken in the left hand test tube. Now, you have to also note, in hard water, you have less amount of foam. Both of these are soft waters. But if you want to make hard water, you can simply add any salt of calcium and magnesium and make your water hard. And try out and explore this experiment with different samples of water. So, you can take your samples and test with different samples of water. So, students, we have learnt about soap. What are detergents? Detergents are sodium salts of long chain sulfonic acids. Soaps do not wash well with hard water because it forms insoluble precipitate of calcium and magnesium salt. Detergents wash well with hard water because it does not form insoluble precipitate of calcium and magnesium salts in hard water. So, students, we need to know the difference between soap and detergents. Soap is sodium salt of long chain carboxylic acid, whereas detergents are long chain sodium salts of sulfonic acid. Detergents clean better than soap. Soaps are biodegradable and usually detergents are non-biodegradable. So, my dear students, let us conclude. You will be able to explain about various reactions like combustion, oxidation, addition and substitution reactions. You will be able to plan and conduct experiment to seek answer to the questions. You will be able to exhibit value of honesty by reporting the observations, and you will be able to communicate the findings. You will be able to make efforts to conserve environment. My dear students, keep exploring and learn more. Happy learning!